right. Hello, everyone. So, welcome to the WasmEdge community meeting. So, in this meeting, we have a special issue about our, LFX mentorship, Linux Foundation mentorship program. So we have 3 mentees who have successfully completed their projects, either using WasmEdge or in the WasmEdge ecosystem. Most of those projects are AI related. So we have them in this meeting to present their work and report, their learnings. So we would have 3 sessions. So the first one would be about BitNet.cpp. So BitNet.cpp is an inference library released by Microsoft. I think Microsoft or Google, that's one of those, So when it was released, it caused a big stir because it can quantize model to 1 bit, instead of, the model will train on 32 bits and then, compressed to 16 or reduced to 16 bits. And then we run it locally on our machines. We typically have like 4 bits, something like that. But the BitNet can compress them all the way to 1 bit or 2 bits, which is really interesting. That's, they can do it so aggressively, and it's open store for running much larger models on smaller devices, right? So without further ado, I'd like to ask Kusha Gora to come and present his work.
Yeah. Am I audible and the screen visible?
Yes, we can see it. Yeah.
Yeah. Hello, everyone. I'll be discussing about the BitNet.cpp plugin. Thank you for the preface. So yeah, this would be the agenda for my discussion. So BitNet.cpp is inference framework, as already mentioned, released by Microsoft. It is a modified version of llama.cpp, but it is more faster, and it does not support TTS or multimodal, but it is much faster for the text prompt, and it will help us expand to users who don't have access to GPUs or need faster inferences over them. Okay, so to build this BitNet.cpp plugin, we have 2 options. That is based on the hardware optimization. So if we have a ARM based machine, then of course we have an option for using that. Or if it is x86, then we have an option to use that. If we select none, or if we select both, the build fails. Because of course, if we don't require any hardware optimization, then it is more preferred to use llama.cpp plugin because it has broader compatibilities. And of course, both optimizations are not possible at the same time. So now, based on the optimization selected, it generates or pre-generates some kernels, which generates the lookup tables, which is basically the reason why BitNet.cpp plugin or the inference is more faster as compared to other as compared to the Llama backend. Yeah, so this was about how we can build from source. Then we have, yeah, this is the standard process as we have for any plugin. I will be releasing the example code in the WasmEdge example repo very soon. But yeah, so of course, as we know, this is the standard WasmEdge plugin command. I will show a demo of how this inference runs, or how this backend works. One second. Just give me a second. Yeah, so this is a command prompt, and I've entered the same command. This represents the file locations of the WasmEdge executable and the .wasm file. And I have already added a prompt once upon a time, which is so that we get the inference. And this is the initial prompt for it. So while this is running, I will be on the screen so that we are able to realize how much faster this is. And so what BitNet.cpp does is, in the meantime, I will explain that. So what it does is it uses some lookup tables, right? So yeah, I've run the code right now. I just forgot to press enter. Yeah. So what it does is it generates the lookup tables based on the kernel that we have selected. So based on if it is TL1 or TL2, it pre-generates some kernels. And then based on that, the backend operates. And yeah, the device that I'm currently on is having 16 GB RAM and it is on CPU. So I think we should be having a response in a few more seconds. So yeah, I won't get into the content of the response, but yeah, we do understand the inference time or the speed it requires, right? So the number of output tokens over here were 508, and it is generally much faster than the backend. So that was the main thing about it. Yeah. So this was about the BitNet.cpp plugin, and that is what I have to share with you all.
Oh, thank you so much. So let me ask a question. Uh, you may have mentioned it, but I may miss. So so the demo you just showing was running on your local computer while you are doing presentation. Is that right?
Yeah.
Oh, cool. So does it have a GPU?
No. It has only CPU and 16 GB RAM. Yeah.
Okay. Um, you know, so uh, so what kind of CPU?
Uh, it has Intel i7 core, and I think other than that, I'm also not aware about it. I will just check it once, and it is an
Okay.
x86. Uh,
Okay.
so
Yeah. Yes. So basically, it's on your own laptop while
yeah,
running other, running other tasks like you are because you are doing video presentation. So I thought that task was
okay.
pretty GPU intensive as well, right?
Yeah. This was concurrently with this meeting as well, right? So
Yeah.
yeah, that's impressive. Yes.
Oh, this is very impressive. Thank you so much. Yeah, that's
Yeah.
we look forward to see how the community react to this. Because with the
Mhm.
design of WasmEdge or LlamaEdge, it's easy for them just to swap out
Yeah.
another backend, right? So it's easy for them to try your work. Thank you. Yeah. Okay.
Yeah.
All right. Yeah. Thanks. Yeah. So very very impressive. That's I thought there will be a lot. Hopefully, there will be a lot more applications like this. Based on this plugin. So talking about applications, let's move on to the next talk, which is from Mohan Kumar. That's so. What we want to build here is a large language model application that built on you know it was built on WasmEdge as an inference engine, but it could use other large language model as well. So we ended up, supporting OpenAI models and other models through the API. So the idea here is to take advantage of agentic features, or tool call features on those models, so that we can build a study assistant, in particular in this case for the Kubernetes certification program. So the idea is that this, we would first develop an MCP server, and which can look up sample questions and answers, and then using this as and then use a large language model to call the MCP server, as the user converse with it, to help user prepare for the certification program. So I think I'm probably doing a very bad explanation of that, so I'll let Mohan to explain it better. So please.
Hello everyone. Am I audible?
Yeah. Yes, I can hear you. Yes.
Yeah. So is my screen visible, everyone?
Yes. Yes.
Yeah. So yeah, my project was ExamBot. So this was an bot that will help students or some professors to prepare for Kubernetes certification exams. So here is the deployed link that I have given in the PPT. So let's dive into the main components of our project. So here we have mainly we have used MCP tools. It is get random question answers. So we have prepared a data set of questions and answers related to Kubernetes certification exam. And what does this MCP tool do? That it selects random questions from the database and presents to you, and with an explanation if you answer it wrong. So here we have saved the whole data set into PIDB, and PIDB gives us a full text search feature which is used for finding the relevant questions. And for privacy reason, all the chats and sessions are stored in browser. So let's move on. So here we have mainly created three data sets. One which is directly used by the product, by the ExamBot, and there are other two data sets that are being uploaded to the Kubernetes. Two are related to the Kubernetes, and third was related to Metal Mine. So, so let's present the ExamBot. One second. So here is a ExamBot our app. So here what this bot uses that whenever when you are preparing for Kubernetes certification exams, it will help you to prepare for the questions that are relevant to the Kubernetes exams. So here it generates multiple choice questions and sometimes some practical questions where you have to write the steps and the commands for it. So here I have asked a question which image full policy. So let's say we write a random option. So it gives the explanation and other things. So so what does this do? That it generates questions and it generates questions from our curated data sets from the Kubernetes. And here we have created the MCP tool to help you find random questions and relevant questions from the database. If the user specifies any topics that he wants to practice, suppose he wants the questions based on the node beat or node heartbeat. So it will fetch the relevant questions related to node heartbeat, and users user can practice it. And the other thing is that this MCP tool, it can be used not for only Kubernetes certification exams. It can be used for any data set and for any certification or any sub academic courses practice where there is a data set and within we have to prepare from the questions of the data sets, and this tool will help to fetch questions and to help you prepare better to score much higher. So here we have, I'll give you another question. Let's dive deep. So here this is my project ExamBot. Thank you all for listening.
All right. Yeah. Thank you, Mohan. Yeah. So, one of those, so I thought one of the more interesting aspect of it, as you mentioned, is there are two components in there. There's an MCP server and there's a chatbot. So the MCP server can be used independently. So, so if you want to use it with another agent, so for instance, you have, say, Cloud Desktop, or you have, in our case, we have another project that developing a voice agent, right? That's it's an interactive devices. So you can have that MCP server to interact with that, to be combined with another chatbot So because that's MCP server would be universally, applicable to all kinds of different, large language model front ends. And the other thing which I thought really interesting that could use a lot more community contribution is to develop more question sets for different exams. So for this project, Mohan developed a question and answer. So essentially you have you develop a spreadsheet. There are 3 columns. The first column is a question. If multiple choice, you would have all the choices given as well. So this is the entire question you see when the exam bot asks you, right? And the second column is the answer. Say B is correct or C is correct, or the correct answer is X, Y, Z, right? And the third column is the explanation. So that's the format. If you have a new data set, you would develop that, and then you would feed that into your into the software, and it would start to generate questions and grade users' answers based on the data you gave it, right? So that means it can be applicable to a lot more, I've seen scenarios where you need a quiz. It's not, the most common scenario would be exam preparation, right? That's you would prepare exam and you have some spare time. So, so people would, you would have it to ask you those questions. But, in other scenarios, you could develop interview questions, right? You could have it automatically interview people for you. And with little, so, I think a good way to contribute to this open source project is to develop more question sets and then, send us as PRs, in the example folder so that, other people can use that as well. So that's, so that's the second project, okay? And so now we want to move on to the third project, which is not strictly AI related, but it's also something we heard a lot of demand. In particular, that people want to run WasmEdge on established hardware. In this particular case, the IBM supercomputer, the IBM mainframe computer platforms. This is one of the challenges because few people actually have this device. So so we would have to to get an environment where this can be developed and done. So this work is done by Mr. Timaya, and so Mr. Timaya, I'll let you present your work and we'll use it. Thanks.
Am I audible?
Yes, I can hear you.
Okay. I think I'm sharing my screen now.
Yes, I can see that. Thanks.
Yeah. So hi everyone. Thank you for taking the time to join my presentation. I'll be sharing the work I've done during my mentorship, which is adding support for the S390 architecture in WasmEdge. So S390X is IBM's 64-bit mainframe architecture. It's part of the IBM Z series. The key difference from most other modern processors like x86 and ARM is it's big endian by default. This specifically is very important later because WASM, the WebAssembly protocol, states that all memory should be in little endian form. It's also a CISC model, which means it has complex. It follows the complex instruction set computing. Essentially, it means that it has a lot more instructions when compared to, say, ARM. It also provides SIMD instructions. This allows parallel computing of multiple values, basically. In terms of operating systems, it supports ZOS, which is IBM's proprietary operating system, as well as Linux distributions like Ubuntu and Debian. Right, so my 3 goals with this project was to first get the WasmEdge interpreter running. For AI workloads, I also added support for the WasmNN plugin, which uses GGML or llama.cpp. WasmEdge also supports a just-in-time and ahead-of-time compilation feature. This is also something I aimed on supporting. Right, so as mentioned before, ST90X is a big endian system. So the primary goal was to add a way to effectively convert data from native endian to little endian, because that's what WasmEdge WebAssembly protocol primarily expects. This also means that SIMD arrays and atomic instructions have to be re-implemented. Further, WASI functions, which are basically system calls for WebAssembly, they let you do I/O and networking. They also have to be adopted to work properly with big endian. So a simple example on what endian is. Endian basically represents the way data is stored in memory. So say you have the bytes hexadecimal value 0, 1, 2, 3, 4, 5, 6, 7, 8. On little endian systems, which is x86 and ARM, it's usually stored as 7, 8, 5, 6, 3, 4, and 1, 2. On big endian, it's the opposite. So it's 1, 2, 3, 4, 5, 6, and 7, 8. Right. So GGML is or Llama.cpp is a cross machine machine learning interface library that allows you to run LLMs and other neural networks. Like I mentioned before, endian issues are the primary problem with porting to this platform. So first we had to rectify endianness before using Llama.cpp on ST90X. Sorry. We've also added support for OpenBLAS, which is basically a library that allows you to perform linear algebra faster using more parallel operations. This is what is used by it uses SIMD basically. A small summary of a few popular models. So you see roughly 20% increase with using OpenBLAS. This was on a 4 vCPU machine that running on a Z15 processor. That's around 2 generations old. I've also added support for the just-in-time compiler and the ahead-of-time compiler. So the problems here was, firstly, we had API differences where the order in which parameters are passed between the generated binary and the WasmEdge process, they're not quite match up, so I had to fix that. I also added support for ST90X specific optimizations, as well as the previous aforementioned endian issues. In the future, this will probably make it easier to support other big endian or mixed endian platforms, as well as IBM's upcoming ZDNN accelerator. This is for newer IBM systems, that is Z17. In the future, I also suppose we could add additional plugins to work with ST90X instead of just WASI and GGB. So yeah, that concludes my presentation.
All right, thank you so much. Yeah, that's you know, I'm really glad that you know, we had the opportunity to collaborate with you on this project, because I think, you know, one of the you know, strengths for WASM is cross-platform hardware support, and this is like you mentioned, you know, those variations of hardware, you know, that's you know, we just have to tackle them one by one, and I really appreciate your help in, you know, in importing this to to this new platform. Yeah, that's sounds great. So maybe we'll see advanced applications like AI inference and things like that, on that platform as well. By having WasmEdge there. So anyway, yeah, thank you. So well, I guess we're a little earlier. That's we had three presentations about 10 minutes each, instead of 15 minutes each. So I have if you guys have questions, feel free to ask. I'll hang around for a while, and otherwise we'll see you in the next month as well. So thank you.